Okay, so this question asks which of the following sequences converge. Let's look at the first one. Sorry, it's not a sequence. It's not a series. N over 2n plus negative 1 to the nth power, n equals 1 to infinity. Okay, so if it goes to infinity, it will be negative 1 to the infinity will be very minuscule, very tiny number, right? So all you have to check for this question is n over 2n plus negative 1 to infinity. So this will be just small enough. When it goes to infinity, it will be just n over 2n, which will converge to 1/2. So this is converging, right? So that means A is not right and D is not right. Right. Okay, let's check the second one. Second one is sine n pi over 2, n equals 1 to infinity. If you look at the sine graph, it's just n, it's like 0, negative 1 to 1, it just oscillates. So it doesn't converge to any value, but it just oscillates until it goes to infinity. So it diverges. So B is not right. 2 is not right. So yeah, B is also not right. You can cancel out. And C is also not right. So our answer will be E according to just like elimination by process. But we can check the 3. Right. 3 is negative 2 to n's power, 3n plus 1, n equals 1 to infinity. So you can write this as negative 2 to the n's power and 3n times 3. I'm just separating into n plus 3, n plus 1 into 3n times 3. So we have that. And then if you look at this, negative 2 to the n's power and 3 to the n's power, you can group that as negative 2 over 3 n times 3, right? And if this value goes to infinity, this will be really small number. You can punch it in the calculator, like you can punch it in something like negative 2 over 3 times 1,000, something like that. And then you'll get really small number and you'll be multiplying with by 3. So if it's like going to the infinity, it'll be like small enough that it's gonna like converge to 0. So it'll be eventually just converging into 0 times 3. So it's converging to 0. So it converges, and that means 1 and 3 are right, and that means our choice E is the right answer, as we expected. So the answer is E. Okay, so this question asks to evaluate 0 to pi over 3 secant to 3 over 2 x tangent x dx. Okay, let's write this first. 0 to pi over 3 secant 3 over 2 x tangent x dx. And we can separate secant 3 over 2x into secant x times secant pi over 2, no, not pi over 2, sorry, 1 over 2x. 1 over 2x, sorry, tangent x dx. There we go. If you look at this, if you put u as secant x, then we can put the derivative as secant x tangent x. So what we're going to do is we're going to put that u equals secant x and put du as secant x tangent x dx. So secant x tangent x dx can be written as du. So we have that. And this is secant 1 over 2x. So this is u 1/2. And then we have to find the bound, right? So u1 equals secant 0. This is, when does this become? This becomes 1, right? Because cosine of 0 is 1, so it's just 1, right? u2 is secant pi over 3. So this value will be 2, because cosine of pi over 3 is 1 over 2. And if you flip the denominator and the denominator, it becomes 2. So it's from 1 to 2. Okay, we just have to integrate it now. Then this is u 3/2 and 2 over 3, right? And from 1 to 2. So this is 2 over 3, 3 over 2 minus 1. So this can be written as 2 over 3, 2 square root of 2 minus 1. So this is 4 square root of 2 minus 2. So the answer for this question is B. Okay, so this question asks to evaluate 1 to e x squared ln x dx. So 1 to e x squared ln x dx. And if you see ln x and x squared, we know that we have to use the integration by parts. So you write logarithmic, I'll write it down, logarithmic, inverse trig, algebraic, and trig, and exponential. You choose a left-right hand side order to choose your u. Since we see ln x, this is L and this is x squared, so it's A. So we see logarithmic function and algebraic function. So L comes first, so our u will be ln x, and du will be 1 over x dx, and dv, it will be x squared dx. So v is x cubed over 3. So if you plug it in that in our formula, ub minus b du, I call it as ub minus budu to just make myself remember it. So that's a tip. So ln x times x cubed over 3 minus x cubed over 3 du is 1 over x dx. So this is 3x cubed ln x minus x squared over 3 dx. This becomes x cubed over 3 ln x minus x cubed over 9, right? And then we have to plug in our bounds. 1 to e, okay? E cubed over 3 ln e minus e cubed over 9 minus 1 over 3 ln 1, and then plus 1 over 9. So this will be 0, ln 1 is 0, and this ln e will be just 1, right? So this eventually becomes, I'll write it above, e cubed over 3 minus e cubed over 9 plus 1 over 9. So this becomes 3 e to the cube minus e to the cube plus 1. So this is 2 e to the cube plus 1 over 9. So that means our answer is A. Okay, this question asks to evaluate from 0 to infinity x squared e to the negative x cubed dx. Let's write it. 0 to infinity x squared e to the negative x cubed dx. We can put u as x cubed, and then we can find the derivative of that, which is 3x squared dx. But we just want x squared dx, so we can put x squared dx is equal to d over 3. Like dividing both sides by 3, then you will only get like x squared dx. Okay, and then let's find a bound. u1 is 0 cube, which is 0. u2 is 0, no, not 0, infinity cube, which is just infinity. So this is from 0 to infinity, and this is du over 3 e to the minus u, right? So let's take out 1 over 3. 1 over 3, 0 to infinity, e to the negative u du. If you integrate it, this becomes 1 over 3, negative e to the negative u, 0 to infinity, and this will be just 1 over 3, negative e negative infinity, plus e to the 0. Negative e to the negative infinity will just go to 0, this is just 0, and e to the 0 is 1, so this is just 1 over 3. So the answer for this question is B. Okay, this question asks to evaluate from 1 to 2, 3x squared minus 1 over x cubed plus x dx. Okay, this is partial fraction decomposition question. Okay, let's write it. 1 to 2, 3x squared minus 1, x cubed plus x can be decomposed as x times x squared plus 1, right? So let's write it down. X times x squared plus 1, right? And then now we can write this into our favorite form, a over x plus b x plus c over x squared plus 1 is equal to 3x squared minus 1 over x squared plus 1. You might wonder why do we write this? Because we can write this as something over x and something over x squared plus 1, because this is one element, right? And then when you're writing the numerator, you have to subtract 1 power. So x to the 1, x is x to the 1 power, so 1 minus 1 is x to the 0 power, which means constant term will go in the numerator. And since we have 2 as our exponent in the denominator, which you subtract 2 minus 1, which is 1 power, which is why we have bx plus some kind of constant as c. That's just how you write for the partial fraction decomposition problem. It's just you kind of have to remember it. Yeah. And then now we have this equation. So we're going to multiply x times x squared plus 1 to get rid of the denominators. So this will be just a x squared plus 1 plus bx plus c. X is equal to 3x squared minus 1. This will be ax squared plus a plus bx squared plus cx is equal to 3x squared minus 1. So this is a plus b x squared plus cx plus a is 3x squared minus 1. So our a is negative 1 because it's the constant term, it has to be. So c, we don't have an x term, so c will be 0. Cool. And then a plus b has to equal to 3. And we know a is negative 1. Negative 1 plus b is 3. B is 4. Cool, cool. So we can write this as negative 1 over x plus 4x over x squared plus 1, which c is already 0, so we don't have to write it. And integrating from 1 to 2, and it's dx. Okay, so we have that. And then if you write this as, we can actually separate it first, right? Let's separate this. So negative 1 over x, 1 over 2, negative 1 over x dx plus 1 over 2, 4x over x squared plus 1 dx. This is just negative ln x from 1 to 2, right? And then plus this part, we can write this as u as x squared plus 1, and du would be 2x dx. If you want to make it into 4x dx, you multiply by 2. So 2 du is 4x dx. So this becomes 2 du over u. And our new bound will be u1. 1 plus 1 is 2. 2. u2. 2 squared plus 1 is 5. So 2 to 5. I'll move this problem so we can actually have a space to write. So so this is negative ln x 1 to 2 plus 2 ln u 2 to 5. So even though we have a different bound, like different variables, it doesn't really matter because we're just going to plug it in the numbers. So you don't have to worry about it. So this is negative ln 2 plus ln 1 plus 2 ln 5 minus ln 2. I put the parenthesis in between because it's 2 multiplied by ln u. So that's why. And then if you write this, then this will be negative ln 2 plus ln 1, which is 0, plus 2 ln 5 minus 2 ln 2, right? This is just same as negative ln 2 plus logarithmic rule. The coefficient can go to exponent power. So this will be ln 5 squared minus ln 2 squared. Negative ln 2 plus ln 25 minus ln 4. So this becomes ln 2 25 minus ln 8 because of the logarithmic rule. So this eventually becomes ln 25 over 8. So the answer for this question is B. Okay, so this question asks to evaluate from 0 to 1 5x squared e to the minus x dx. Okay, so we see 5x squared and e to the minus x. So we are going to do not partial fraction. It's the integration by parts. So we're going to write the Lyot formula as we write L is log, I is inverse trig, A is algebraic, T is trig, E is exponential. And we see algebraic and exponential. So u will be our 5x squared because a comes first. And dv would be e to the negative x dx. So du would be 10x, b would be negative e to the negative x. Let's write that, ub minus b du. So this becomes 5x squared minus e minus x plus e to the negative x times 10x dx. Oh, you have to do it again because we have 10x and e to the negative x. Then we have to do the partial fraction, not partial fraction. I kept saying that, sorry. The integration by parts again. Okay, fun. Let's put another u as 10x. Actually, let's put u as u2 to differentiate from the first u. u2 is 10x, then u2 prime would be 10, and v2 would be e to the negative x dx. So v2 would be negative e to the negative x. So let's write this part again. This part would be, so if you remember, u2 v2 minus v2 du du2, which I'll write this as du2 just for the sake of understanding, easy, I guess. Just for the sake of like easy to understand. Sorry, I cannot talk apparently. So u2 is 10x and v2 is negative e to the x. So this is negative 10x negative e to the negative x plus e to the negative x, and then times 10. Oh, nice. Now we don't have to like do integration by parts again because it's constant term right there. So this will be negative 10x e to the negative x plus, oh, this will be negative 10 e to the negative x because there's a negative sign on the power. So this will be that. And now you have to add this part and that part. So let's write it in here. Negative 5x squared e to the negative x minus 10x e to the negative x minus 10 e to the negative x. Okay, we have that. And our bound was 0 to 1. Let's plug it in then. Negative 5 e to the negative 1 minus 10 e to the negative 1 minus 10 e to the negative 1. And if you plug in 0, this term will have 0 because we have x squared and x. And then this will be just 10 e to the 0. So this will be negative 5 over e minus 10 over e minus 10 over e plus 10. This is e negative 25 plus 10. So which is e. So the answer for this question is E. Okay, so this question asks which of the following improper integrals converge. Let's look at the first one. 2 to infinity dx over x. This is ln x 2 to infinity, right? So ln infinity minus ln 2. ln infinity is just infinity minus ln 2. This is just infinity, so this one doesn't converge. So this is not right, meaning A, B, and A, B are not the answer. Okay, let's look at the option 2. 0 to 1 dx over x squared. This can be written as 0 to 1 x minus 2 dx. And if you integrate that, that becomes negative x minus 1. This is from 0 to 1. And you can write this as negative 1 over x, 1 to 0. So this is negative 1 plus 1 over, oh, sorry, you have to do the, right, that is right, right. Well, I don't know what I was thinking. Negative 1 plus 1 over 0. So 1 over 0 is undefined, right? So this is negative 1 plus undefined. So the answer for this, answer for this 2 is undefined. So 2 is not right. So 1 and 2 are not right. So C and D are not right. So I'm assuming E is our answer, but I'll just show why it's E. So 3 is 3 to 5 dx over x minus 3, 1/2. And you can write this as 3 to 5 x minus 3 negative 1/2 dx. This is just x minus 3 half 2 integrating from 3 to 5, right? Okay, let's plug it in. Then 2 half minus 2 0 half. 2 0 to the half is just 0, so this is just 0. And then this will be 2 square root of 2. So this is actually converting into 2 square root of 2. So the value exists. So it's 3 converges. So the answer for this question, as we expected, it's E. Okay, this question asks which of the following, not which of the following. The following function has a partial fraction decomposition, and find D. Okay, let's write it. X cubed minus 14x squared minus 3x plus 2 is over x cubed, x to the 4th power minus x squared is equal to a over x plus b over x squared plus c over x minus 1 plus d over x plus 1. you can decompose this x to the fourth power minus x squared as, you can group them at first, right? X squared minus 1, and then you can separate that x squared minus 1 into x plus 1, x minus 1, right? Now let's write that in our denominator. X cubed minus 14x squared minus 3x plus 2, x squared, x plus 1, x minus 1 is equal to a over x plus b over x squared plus c over x minus 1 plus d over x plus 1. So we don't want like the denominators, so we're gonna multiply out by x squared, x plus 1, x minus 1 on both sides to get rid of the denominators. X cubed minus 14x squared minus 3x plus 2 is equal to ax, x plus 1, x minus 1 plus b, x plus 1, x minus 1 plus c x squared, x plus 1 plus d x squared, x minus 1. Okay, so what I would recommend is not expanding those and just plug in the values for x to find d value. Let's plug in x equals 0. So x equals 0 on both sides, then this will be just all 0, so this is just 2 is equal to, this will be 0 because we have x equals 0. This is not going to be 0, so this is going to be negative 2b, right? And then this will be 0 because we have x squared, and this will be also 0. So we got b is negative 1. That is not what we want, but we are going to go through that. So x equals negative 1. Let's try that. So negative 1, then it's going to be negative 1 minus 14 plus 3 plus 2. If you plug in negative 1 in here, this term has negative, if you plug in negative 1, this term will be 0. So this will be 0. This will be also 0 because we have x plus 1. And this will be also 0 because we have x plus 1. So if you plug it in here, this will be d times negative 2. So this is negative 10. This is negative 2d. So d is 5. Right. And what we're supposed to find? We're supposed to find d. So there you go. We already found d. So we're done. So the answer for this question is A. Okay, this question asks to evaluate from 5 to 10 square root of x squared minus 25 over x. Okay, so 5 to 10 x squared minus 25 over x dx. And since we see x squared minus 25, we can use trig sub. You know, x squared minus a squared is equal to x equals a secant theta. In our case, a squared is 25, so a is 5. So this is x equals 5 secant theta, right? We have that. And then we can find dx is 5 secant theta tangent theta d theta. And let's write x let's find theta value in terms of x. So this will be x over 5 is equal to secant theta, and theta is then secant inverse over x over 5. Not over, but secant inverse x over 5. Let's find the value lower bound. So theta 1 is secant inverse 5 over 5, which is secant inverse 1, which is that's 0, right? And then theta 2 secant inverse 10 over 5, which is secant inverse 2, which is cosine of 1 over 2, which is pi over 3, right? So we have everything that we need to know. So this is from 0 to pi over 3, because that's our lower upper bound. And then x is 5 secant theta, and then this is 25 secant squared theta minus 25 times secant theta tangent theta d theta 5, I forgot. Sorry. So 5 secant theta will be cancelled out, right? This is 0 to pi over 3. 25 secant theta minus 25 times tangent theta d theta. If you remember your trig identities, which you should for this midterm specifically. So secant theta minus 1 is equal to tangent theta, tangent squared theta. So 25 secant squared theta minus 25 is equal to 25 tangent squared theta. So this is 0 to pi over 3, 25 tangent squared theta times tangent theta d theta. So 0 to pi over 3, 5 tangent squared theta d theta. And we know tangent theta is 5 sine theta cosine theta, right? Tangent theta is equal to sine theta over cosine theta, so we use that. And then write squared d theta. So this becomes 0 to pi over 3, 5 sine squared theta over 5 cosine squared theta d theta. And if you remember your trigonometry, again, sine squared theta plus cosine squared theta is equal to 1. Sine squared theta is equal to 1 minus cosine squared theta. So this is 0 to pi over 3. Our 5 will be, yeah, we can just leave the 5 right there. Let's just actually take it out, the 5 outside of the integrand. So let's take out the 5 out. And then let's write sine squared theta as equal to 1 minus cosine squared theta, 1 minus cosine squared theta over cosine squared theta d theta. So this is 5, 0 to pi over 3, 1 over cosine squared theta minus 1 d theta. And this is 5, 0 to pi over 3. 1 over cosine squared theta is same as secant theta, secant squared theta, and minus 1 d theta. And we know that secant squared theta is 5 tangent theta, right? And then theta is just 1 is just negative theta, right? So that's what we got for the when we integrate like secant squared theta minus 1. And then now you have to plug in the values, 0 to pi over 3. So this becomes 5 tangent pi over 3 minus pi over 3. Entire thing multiplied by 5, and then minus 5 tangent 0 plus 0. Well, tangent 0 is also 0, so it's cancelled out. Cool. So this is it. 5 tangent pi over 3 minus 5 pi over 3. 5 tangent pi over 3 is same as 5 square root of 3 minus 5 pi over 3. So if you go all the way back to our answer choices, that's the answer choice A. So the answer is A. Okay, so this is asking about which of the following recurrence relations will generate a sequence of A3 equals 3 over 4. There's no other way. You just have to plug it in the numbers. So let's do that. So A is A1 is 1 over 2. A2 would be 1 over 2 squared plus 1 over 2. So 1 over 4 plus 1 over 2, so 3 over 4. A3 would be 3 over 4 squared plus 1 over 2. So this is 9 over 16 plus 1 over 2, so which is 17 over 16. So that is not right, because we want to find A3 equals 3 over 4. B is A1 is equal to 1. A2 is 1 over 2, because A1 over 2 is 1 over 2. A3 is 1 over 2 times 1 over 2, which is 1 over 4. So that's also not right, because I wrote this as 1 over 2 times 1 over 2, because we have to write 1 over 2 over 2, which I feel like if we write it this way, that people might make a mistake, and I also make a mistake like that, so I like to write it in the 1 over 2 form, because if you're dividing by 2, it'll be just same as multiplying by 1 over 2. So I like to write it in this way, so I don't have to like worry about algebraic mistake. So that's why I do that anyways. And then going back, A3 is not equal to 3 over 4, so B is not right. Cool. So C, we are given A1 is 1, and A2 would be then negative 3 over A1, which is negative 3 over 1, which is negative 3. A3 would be negative 3 over A2, which is negative 3 over negative 3, which is 1. So that's also not right. Cool. Let's try D. A1 is 4. Okay, A2 then is A1 minus 1 over 4, which is 4 minus 1 over 4, which is 15 over 4. A3 is A2 minus 1 over 4, so 15 over 4 minus 1 over 4, 14 over 4, which is 7 over 2. So D is also not right. E is A1 is 0, A2 will be A1 plus 1 over 2, so 0 plus 1 over 2, 1 over 2. A3 is 1 over 2 plus 1 and divided by 2, right? So this is 3 over 2 divided by 2, which is 3 over 2 times 1 over 2, so 3 over 4. So this is the right answer, and by elimination of process, we already figured out E will be our answer, and we also confirm that it's 3 over 4 by calculating. So that is the answer. Okay, this question asks to evaluate sine to the fourth power x dx. Okay, sine to the fourth power x dx, which is same as sine squared x squared dx, right? And if you remember your double angle or half angle theorem thing, sine squared x is 1 minus cosine 2x over 2, right? So if you square that, sine squared x squared is 1 minus cosine 2x over 2 squared. Oh, that's gonna be fun. Let's take out 1 over 2 first. Actually, 1 over 2, 1 minus cosine 2x. The entire thing is squared. So 1 over 2 squared is 1 over 4, right? This is 1 minus 2 cosine 2x plus cosine squared 2x. So this becomes 1 over 4 minus cosine 2x over 2 plus 1 over 4 cosine squared 2x, right? We have that, and now we have to integrate it. Oh, actually, we have cosine squared 2x, right? We can actually like write this into like double angle or half angle. I don't remember which one is which, but I know the formula. So there you go. You have to remember it for this midterm. Cosine squared x is same as 1 plus cosine of 2x over 2. Since we have 2x, this will be cosine squared 2x is equal to 1 plus cosine 2 times 2x over 2. So this becomes 1 plus cosine 4x over 2. So this can be written as 1 over 4 minus cosine 2x over 2 plus 1 over 4 times 1 plus cosine 4x over 2. So this is 1 over 4 minus cosine 2x over 2 plus 8, 1 plus cosine of 4x. And now you can integrate it, this thing, which is great. 1 over 4 minus cosine 2x over 2 plus 1 plus cosine of 4x over 8 dx. This is 1 over 4 minus 4 over minus sine 2x over 4, right? Plus, you can write this as 1 over 8, right? So this is going to be 1 over 8x. And then plus cosine 4x over 4. I should separate this. I'll just separate it right now for the sake of like easy to understand for that. I cannot talk apparently for the sake for you to understand it. So 1 over 8 plus cosine 4x over 8 dx. There you go. You separate this part into like that, so it's easy to like integrate it. So this is 1 over 4x minus sine 2x over 4 plus 1 over 8x, and then plus sine 4x over 32, right? So there you go. And since it's indefinite integral, so you have to put plus c. That's the most important part. So if you look at our answer choices, oh, we can simplify this, right? I forgot. We can add those, right? So this will be just 32 over 8x plus 32 over 4x minus, why are we going 32 actually? I could have just done it in this common denominator 8, right? Oh, okay. 2x over 8 plus x over 8. There we go. Minus sine 2x over 4 plus sine 4x over 32 plus c. Right, so this becomes 3x over 8 minus sine 2x over 4 plus sine 4x over 32 plus c. So that's the answer choice A. So the answer for this question is A. Okay, this question asks to evaluate dx over 1 plus 9x squared 3 over 2 power. Cool, let's write it. Dx over 1 plus 9x squared 3 over 2 power. I'm sorry for the background noise. I can't control my neighbors for closing the door. It's so loud. So, sorry. So this is dx over, we're going to group it by 9. Okay, so this is going to be 9, 1 over 9 plus x squared 3 over 2 power. So since we remember that x squared plus a squared, you can write it as x equals a tangent theta. And then we know our a squared is 1 over 9 if you write it in this format. So a is 1 over 3. The only reason that we group it by 9 is then we can write it as x squared plus a squared format. That's easier to visualize and it's easier to like write it down the formula. So that's why. So our a is 1 over 3, so x is 1 over 3 tangent theta. And our dx will be 1 over 3 secant squared theta d theta. Cool. So let's write it. Dx is 1 over 3 secant squared theta d theta, and 9 3 over 2 1 over 9 plus 1 over 9 tangent squared theta, and then 3 over 2 power. Please remember your trig identities for this midterm, please. This is gonna be like helping you a lot in the midterm when you're taking it. So 1 plus tangent squared theta is equal to secant squared theta multiplied by 1 over 9. So 1 over 9, 1 plus tangent squared theta is equal to 1 over 9 secant squared theta. 1 over 9 plus 1 over 9 tangent squared theta is equal to 1 over 9 secant squared theta. So this part is just 1 over 9 secant squared theta. Okay, let's write it. 1 over 3 secant squared theta over 1 over 9 secant squared theta 3 over 2 power. Cool, we have that. Okay, and then 9 to the 3 over 2 power, which is, I'm going to write it in here, 9 3 over 2 is same as 9 is 3 squared, right? 3 squared 3 over 2, so 2 canceled out, so this becomes 27. Cool. So this is 1 over 3 secant squared theta d theta over 23 1 over 9 3 over 2 secant squared theta 3 over 2 power. And 1 over 9 3 over 2 power is just square root of 1 over 9, which is 1 over 3, and multiply by and then it's not equal, right? Let's write it. Square root of 1 over 9 is 1 over 3, and then if you cube that power, that becomes 1 over 27, which is then 1 over 3 secant squared d theta. Oh, I erased it, sorry. 27 times 1 over 27 secant 2 canceled out, cube theta. So this thing canceled out. So this is 1 over 3 secant squared theta over secant cube theta d theta. This eventually becomes 1 over 3 secant theta over 1 d theta. I mean secant 1 over secant theta, because secant cube is in the denominator, right? My handwriting is getting messier. I see. Sorry. There we go. So this is just 1 over 3 cosine theta, right? Which you have to integrate it. Wait. Oh, we didn't integrate it. Oh, where did the integration go? Oh, sorry. So 1 over 3, 1 over secant theta is same as cosine theta. And then if you integrate this, then this becomes 1 over sine theta plus c. Okay. But if you remember it, you wrote it in terms of theta. So we have to find the theta. Let's draw our triangle. We recall that x equals 1 over 3 tangent theta. That means 3x is equal to tangent theta, right? Multiply by 3, then you get this equation. That means 3x is here, this is 1, and the hypotenuse will be 9x squared plus 1. Now let's find sine theta. So the sine theta would be 3x over 9x squared plus 1. Do you remember your Sokata thing? Yeah, you should remember it. So that's the sine theta. So 1 over 3 times sine theta, which is 1 over 3 times 3x over square root of 9x squared plus 1. 3 canceled out, and then plus c. Oh, sorry, I should have put plus c too. Yep. So this becomes x over square root of 9x squared plus 1 plus c. Yeah, plus c is the most important part, as far as I think. You might not agree, but that's okay. So the answer for this question is this is x over 9 square root of 9x squared plus 1, which is c. Okay, so this answer is c.